Welcome back, everybody. Moving on to another question, another inequalities question. So we got to solve these two inequalities here. These are a little tougher than ones we're used to because they have denominators in them, but overall still not too bad. So let's start off with this one. We got 2x minus 1 times x plus 3 over 5 greater than or equal to x plus 4 over negative 6. So what we want to do is we want to multiply both sides by a lowest common denominator between 5 and negative 6 to get rid of the denominator, so we don't want to work with them. So let's multiply this side by 30, and you always want to multiply it by a positive number, because if you multiply by a negative number, then you're going to have to flip this sign here, right? So even though we have a negative denominator, you're always multiplying everything by a positive lowest common denominator. So multiplying both of these expressions by 30, notice that 5 goes into 30 6 times, so this left side will be 6 bracket 2x minus 1 x plus 3 greater than or equal to negative 6 goes into 30 negative 5 times. So we'll have negative 5 up here, x plus 4. And now it just becomes a regular polynomial inequality. So we have to expand everything, bring it all over to one side, and then solve. So to simplify everything, I FOILed these two brackets out. I ended up with 2x squared plus 6x minus x minus 3. The 6 is still on the outside. Brought this negative 5 in the bracket, so negative 5x minus 20. Simplified this 6x minus x into positive 5x, and then I was able to bring this 6 inside the bracket. So we end up with 12x squared plus 30x minus 18 is greater than or equal to negative 5x minus 20. So what I'm going to do is I'm going to bring these over. So we'll have 12x squared and then 30x plus 5x, right? This negative turns into a positive when we bring it over. That would be positive 35x if we add it to that like term. And then negative 18 plus 20 would be positive 2. And this is going to be greater than or equal to 0. So notice how we have a quadratic greater than or equal to 0. And now what you want to do is you want to check if you can factor this. Notice how we can't take anything out, no constants, no variables either, because this 2 has no x attached to it. And notice how it's not going to factor smoothly either. Because if we take 12 times 2, that's 24, two numbers that multiply to 24 and add up to 35, that's impossible. So at this point what we have to do, the only tool we have left with to use is the quadratic equation. So if we continue this question over here, plugging in the a, b, c value into the quadratic formula, doing all that algebra, you end up getting x equaling negative 2.86 and x equaling negative 0.06. So at these x values, this quadratic is going to have a value of 0. So basically those are your x-intercepts, right? So they're not too smooth, but what you can do is you can plot them on a graph. So we'll have negative 0.06 here, and then let's say negative 2.86 here. And this is a quadratic that is opening up, right? Because it has a positive a value, right? So the end behaviors, it has an even degree, a positive leading coefficient. So the end behaviors are something like this. So if we graph this quadratic, it's going to look something like that approximately, right? So when is this quadratic greater than or equal to 0? Well, when x is greater than or equal to negative 0.06, right, from that x-intercept and on, this quadratic is going to be greater than or equal to 0, so above the x-axis, so that's one of the solutions. X is greater than or equal to negative 0.06. It's going to be negative here, and then again positive when x is less than or equal to negative 2.86. And those are your final answers, right? And you can also show this in set notation. So x being greater than or equal to negative 0.06, that would be like negative 0.06 in square brackets to positive infinity, right? X is an element of that. And then this one would be x is an element from negative infinity to negative 2.86, and that's in square brackets. Right, from negative infinity to negative 2.86, the function is positive or equal to zero, right? It's above the x-axis. And the same thing here, from this x value negative 0.06 to infinity, function is above the x-axis, it is greater than or equal to 0. So these two are your solutions to this inequality. So now let's move on to part B right here, and I erase part A because part B we're going to need a lot more room for. So same thing as in part A. What you want to do is you want to first get rid of these denominators. So what's the lowest common denominator between 4 and 6? Well, 12, right? So let's multiply this whole expression by 12, and then this whole expression by 12. Now, another point I want to make is, let's say that this inequality also had another term here. Let's say maybe we had like 2x. Well, we'd have to multiply this 2x by 12 as well. Basically, everything gets multiplied by that lowest common denominator, right? So just be aware of that. Same thing here. If we had another term being added or subtracted, we would multiply that term by 12 as well. So 4 goes into 12 3 times, and then 6 goes into 12 twice. So we can rewrite everything as 3x bracket x minus 4 x plus 3 less than or equal to 2 bracket x plus 4 x minus 7. So further simplifying this, what you want to do is you want to FOIL out these two brackets. You'll end up with x squared minus x minus 12. Foiling these two brackets out, you end up with x squared minus 3x minus 28. Then you could bring this 3x inside this bracket. So we got 3x cubed minus 3x squared minus 36x is less than or equal to 2x squared minus 6x minus 56. And now notice this is just a regular polynomial inequality. So what you want to do, you want to bring everything over to one side. So I'm going to bring all of these terms on the right over to the left side. So we got 3x cubed. Bringing this positive 2x squared over, it becomes minus 2x squared. And that's a like term with negative 3x squared. So negative 3x squared minus 2x squared, that would be minus 5x squared. Negative 36x plus 6x would give us negative 30x. And then bringing this negative 56 over, it just becomes positive 56, less than or equal to 0. So we now have a polynomial function on the left side, and we have to find out when is it less than or equal to 0. Now notice this is a cubic function, so what we have to do is we have to factor it. So first thing you check, can you take anything out? Well, notice we can't take any constants out. And we can't take any variables out because this 56 has no x attached to it. Okay, can we do this by grouping perhaps, right? When it's a cubic, you always want to check, can you factor by grouping? Well, if we take out an x squared from these two terms, we'll have 3x minus 5 at this point. And then from here, what can we take out? I guess a 2, a negative 2. So we'll have 15 plus, or 15x rather, minus 28. Anyway, either way, grouping is not going to work because this bracket are different. So unfortunately, what we got to do is we got to use the factor theorem, right? So we have to plug in numbers by trial and error, plus or minus 1, plus or minus 2, etc., etc. So if we let this whole polynomial here be f of x, we got to plug in f of 1, f of negative 1, f of 2, f of negative 2, etc., etc., until we get something equaling 0. So if we plug in 1 for all of the x values here, that won't be 0. If we plug in negative 1, we won't get 0 either. But if we plug in 2 for all the x values in this polynomial, we will get 0. So what that means by the factor theorem is that x minus 2 is a factor of this polynomial. So we could take this polynomial and divide it by x minus 2. And we could do that on the side here. So we'll have x minus 2, and we're going to divide it into 3x cubed minus 5x squared minus 30x plus 56. And when you do that long division, you end up getting this result here. So you get 3x squared plus x minus 28 as the quotient, and you should get a remainder of 0 there. Right? So what we've done so far is we've taken this polynomial here on the left side, and we broke it down into this divisor, x minus 2, and then this quotient here, 3x squared plus x minus 28. And we're still finding when is it less than or equal to 0. So at this point, what we got to do is we have to factor this quadratic. But if you try to factor that quadratic, so if you multiply 3 and 28, and then try to find two numbers that multiply to that number, to 3 times negative 28, and then add up to positive 1, you won't find any. This is not going to factor smoothly. So what we have to do at this point is we have to find the intercepts of this quadratic, basically when this quadratic is equal to 0 with the quadratic formula. So what we would do is we would plug in negative 1, right, negative b plus or minus the square root of b squared minus 4ac all over 2a. So it'd be plus or minus b squared, which would be 1 squared minus 4 times 3 times negative 28. And this is going to be all over 2 times a, which is 2 times 3. And when you end up doing that in your calculator, you get two x values, 2.89 and negative 3.23. So what does this mean according to our inequality? Well, let's actually forget about this inequality for now, and let's just graph this polynomial, right? So if we were to graph it, we already know that x equals 2 is one of the x-intercepts. And then we also know from this quadratic equaling 0 that these two would be the x-intercepts also of this cubic function. So the x-intercepts from this is going to be 2.89 and negative 3.23. All right, so erasing all this here, let's graph this cubic function. So because it's a cubic function, it has an odd degree and it has a positive leading coefficient. So we know that the end behaviors are going to be from quadrant 3 to quadrant 1. What's the y-intercept? If we plug in 0 for all the x values, either here or here, it's easier to do it in the expanded form. It's going to be positive 56. So that's up here. And then the x-intercepts are these figures here. So negative 3.23, which would be down here. Actually, let's put that over here. And then we'll have 2. Let's put it down here. And then we'll have 2.89. Right? And then none of these x-intercepts have an even order, so it's going to go through the x-axis for all of them. So basically, this is going to look something like this. Right? You don't need an exact graph, right? You just need an approximation. And now from this graph, we can tell when is this function going to be less than or equal to 0. Well, it's going to be less than or equal to 0 in this interval here. So one of the solutions would be x is greater than or equal to 2, less than or equal to 2.89, right? If we want to put that in set notation, it would be from 2 to 2.89. And it's inclusive, that's why we have the square brackets there, right? Because it's greater or less than or equal to 0. It's also less than or equal to 0 in this interval here, right? Below the x-axis for x values that are less than or equal to negative 3.23. So that's the other solution. And if we put that in set notation, it's basically x is an element from negative infinity to negative 3.23. That negative 3.23 is in square brackets, right? So these are the two solutions, right here and right here. So a lot of work with this inequality. We first had to get rid of the denominators by multiplying everything by 12, the lowest common denominator. Once we get rid of the denominators, we have to expand everything, bring it over to one side. We were able to get a smooth factor of 2 with the factor theorem, but then at this point, this quadratic doesn't factor smoothly, so we have to find the intercepts of that quadratic with the quadratic formula. And we ended up getting these decimal values. And then once you have those, I just recommend graphing this and then seeing when is the function less than or equal to 0, here or here. If it was greater than or equal to 0, you'd be looking at these intervals over here, right? So fairly complex, lots of steps, lots of potential to make mistakes. So just be really careful with your algebra when you're doing these.